Dear Chairman, Organizer and participants of the conference, I'd like to represent you the investigation of Kuchar Institute of Bioorganic Chemistry and Petrochemistry of the National Academy of Science of Ukraine deal with the improved the municipal wastewater treatment technology in towns and villages. A typical technological scheme of aerobic wastewater treatment is shown on this slide. In the terms of construction, it can have a different implementation for each of the building objects. At the same time, the specified technological principle is preserved with minor changes. The main disadvantages of these technologies are utilization of raw sediments. 60% of electricity is spent on the air tank, a large amount of excess sludge, and low speed of water returned to aerobic sludge. Over the past decades, aeration tanks with extended aeration have been included in the practice of biological treatment of domestic or similar sewage effluents. But they are turned out to be economically unfeasible. An alternative solution to aerotanks of extended aeration is treatment of the entire volume of domestic sewage in anaerobic psychrophilic reactor. According to the inflow of effluents to the structure, it was established that the operation of the psychrophilic reactor can take place in two modes: the USB mode, a reactor with a fixed layer of bottom sludge, and AGSB mode, a reaction with an expanded sludge layer in the bottom part of the reactor. The Kamenskyh wastewater treatment plant was chosen as the basic experimental site. The determined characteristic of the process and the evaluation of the pollution subject to such process allowed starting work on the calculation methodology of psychrophilic devices with a flow of liquid. According to the scientific project, the entire volume of wastewater is subject to treatment in anaerobic psychrophilic condition from the very beginning. An integral part of the process is also the decomposition of suspended organic substances that are kept in the flow of liquid in the working volume of the reactor. In this way, two problems are solved at the same time. The first is the preliminary purification of water itself, and the second is the deep destruction of sediments and the destruction of excess microorganisms that cleansed the water of pollutants. Based on the above research, we proposed a new municipal wastewater treatment technology that was called bioconveyor. Bioconveyor facilities for the carbon, nitrogen and phosphorus compounds removal are schematically shown in the next slide. Slide 5 shows the aeration tank of periodic action which works under aeration conditions: carbon oxidation and nitrification of ammonium nitrogen and removal of orthophosphates. And on slide 6, it works in condition of determination removal of carbon compounds that aeration of aeration tank is turned off. Anaerobic treatment of wastewater in psychrophilic condition provides a significant 4- or 5-fold reduction in dry matter sludge with good water yield properties. Reduction on the other areas silt slides allows creating an expensive project of the sewage purification facilities for new construction of specific power consumption of less than 0.2 to 0.5 kilowatt hour per square meters of treated wastewater. The bioconveyor station is made of the single closed block. In the underground part, sewage treatment removed biomass and excess microorganism destruction which purified water take place. Various technological equipment, control and management system, administrative and household and warehouse premise are located in above ground part. Emission gases released from the process tank are cleaned and disinfected before being released into the atmosphere. Air conditioning is provided and administrative and domestic premises, and ventilation is necessary in production areas to create a safe atmosphere. This slide presents the body design of this station. Thank you for the attention.